Okay, today in this part on the RZR Mini Multiplexer, I'm actually going to do a repair on one of the older boards to test some new features and run some code on. The main thing that I want to look at today is I'm really interested in see if I can get the light bar to actually kind of fade in and fade out. My light bar in particular, it's 180 watts. And it's really at dead night turning that on really does affect people's vision, and it brings a lot of attention. And I want to see if I can do kind of a soft start, which I think will be a really cool feature. It's really similar to what you see in car interior lights, how they'll dim down and dim back up. My light bar in particular is pretty much a raw LED module. So it shouldn't have any problems. That doesn't mean every light bar is going to work that way. If they have a lot of circuitry in them, they may not like a PWM. But I'm going to make it optional in this software that we put here. One of the issues with this is actually an older runner board. This was actually one of the very first designs where I was basically using a standard large FET, as you can see from the footprint there. But everything else pretty much on this design really didn't change. So I have all the input circuitry. I have the 485, and if I really wanted to, I could actually attach one of the. If you remember this from the first video, this isn't the same series, but this is definitely the same type of FET, and the signaling will still work. So I could actually attach these together and simulate something I want to, and that's exactly what I plan to do. I may not get to it all in this video, but I just kind of wanted to go over, here's a old proto board, and the design continues to evolve, and this is more of a writing the code thing. It's kind of difficult to actually write code with the one that's in the RZR. I've actually got that mounted. It's got conformal coding on it. I can plug into the programming header, but it's pretty difficult. I have basically a leash of the USB cable, and it's not been that bad. I have found that it's pretty easy to do, especially if it's inside the toy hauler where it's relatively cold right now. But if you're inside the toy hauler, you can kind of work around. But it's still a lot easier just to be able to take this in the house and kind of code away and see how things work before we actually put it in a real unit. So initially what we're going to do today is I'm going to touch this board up a little bit and get it actually working again. I basically had mangled it just doing testing. I destroyed a part or two. I did all my reverse polarity testing on this board, and got happy with the results, but obviously I did some damage intentionally to this board just to see what kind of abuse this thing would take. So let me get to this. I'm going to go ahead and rewire. I pulled up a trace that actually supplies 5 volts to the opto isolator, and I'm going to rewire that here just so I can actually use this board for input testing. One thing I'll just mention, I got a couple of private messages about the soldering. A lot of people have really just seen the end of this iron. I actually have another video where I explain this. But these are Metcal or Thermotronics soldering stations. And they're probably, everywhere I've seen in the industry, like the professional use, this is what they use. And that's why it looks so easy. A lot of people sent a message wondering how I was getting these large wires soldered on and what I plan to do when I did more current. That'll basically, you can take a 9/16 inch bolt and nut. They've got a YouTube video somewhere and you can actually solder those two together. So that's how much heat these can actually put out. They're precision instruments though, so you can get a very large tip and work with really big things, and they also make very small tips, which are really accurate and really easy on parts because they heat quickly. They transfer a lot of heat, and you don't really overheat things, but if you need the heat, it's there. And I did a really short video explaining, I think the title of it's Good Soldering, but if you have any more questions, just take a look at that video. They're pretty easy to get on eBay, and a new one's not too expensive. I think there's 2 companies now that actually make them. Let's see, we are going to connect pin 8. I've tested with the voltmeter. We still have 5 volt power on the RS485, so I'm probably just going to jump over from the pin from it up to this new opto isolator that I installed. This is kind of precision work. This is really small wire. This is typically what you would do on a damaged circuit board. And it's probably not anything you'd want to try to do without some kind of optical assistance. At least I can't. My eyes are getting pretty old at this point. Yeah, I'm really glad that I did that. That part just kind of fell off. Now I'm just going to check and make sure that this is going to be connected to what I think it's going to be connected to. Okay. So for those of y'all that don't know, the opto isolators typically, this is a, I think a 714, maybe 741. Basically, it's a light source and then a photosensitive or optical sensitive transistor. So basically, what I'm connecting here is the 5 volt leg that actually goes in, and you know these are low side type transistors. So what I'm going to do is just connect one of those pins to 5 volt, and then I just verified that all the pins that should be 5 volt on the transistor side are actually connected. Okay. Just one more verification. If anybody's wondering why I'm being really careful, I usually am careful anyway, but you know, I've already smoked several of these parts today on these boards, because basically what I'm doing is doing reverse polarity testing against the finished board. The finished board actually has protection diodes and is actually following spec for all the parts. These initial run boards, I actually did not completely do polarity protection on all the devices because it was based off of a design that I had in another project that I wasn't worried about reverse polarity. But the finished boards are reverse protected. I just wanted to do a test to see how sensitive these parts were. And believe it or not, most of them were actually okay. The only time that they really had problems, which I would probably see on the RZR, is around 17-18 volts. They had some type of breakdown and, you know, let the magic smoke out. I'm just going to check this here and make sure that it's connected the way that I think it should be. And basically I'm going to check each one of these pins that should have 5 volts on them. Just make sure we don't have any kind of weird short to ground. Check check on the back side here and check this regulator section. Okay, we look good. Only short to ground is the ground itself. Okay, I'm just going to let the camera roll. We're going to hook it up and see what happens. What should happen, what we're looking for is, I've got a little low voltage or low current switch attached here, and hopefully now we'll see this opto oscillator will actually send a 5-volt signal to the microcontroller. This switch is actually controlling 12 volts, and basically that's just isolating the 12 volt from the 5 volt that's on the board. Let's just make sure we have current limiting on here. Okay. No smoke, but let's make sure that it's actually doing what we think it's going to do. I'm just going to pull up the schematic here real quick, or the PCB file in CAD or KeyCAD. And look at which one of these inputs that we're actually wanting to check. Ooh, and we're upside down. So we should need that pin there. And there we go. I'm not really sure you can actually see the meter. If not, you'll have to take my word for it. But basically on that pin, we don't have any voltage, and when we key up the switch, it goes to 5 volts. So that's exactly what we're looking for. I just kind of want to show you what we actually did here. It's a little bit better shot. I'm not sure if the camera's going to get focused on that or not, but there's actually a little jumper wire here that jumpers the 5 volt that's on that really small 485 driver to that opto oscillator. And then the opto oscillator, basically what we're doing here is we've got current limiting resistors here on the back, and then 4 inputs, and each one of those current limiting resistors basically is going to power this LED side of this opto oscillator at its recommended current throughout the range. And I think I've tested this down to about 3 volts, and this still actually works. Like if your battery was very low, this would still work. Now in my application, I'm actually I'm kind of telling this to turn off if the voltage is really low, because the last thing I want to do is actually draw my voltage down to where my engine stops with an LED bar. If I had a voltage regulator problem or something like this is going to give me an indication that something is wrong. It's going to want to start shutting things down and hopefully let me limp home. But that's just one of the cool things about being able to actually digitally control the stuff in the RZR. And you see this in a lot of other things. It's just, really, there's not a real big application for really small stuff.